Okay, let me start. So previous day we were having one question. Let me take the question also. Can you see my screen?
Yes, ma'am.
Okay, let's continue. Okay, so our question was that we were having a trapezium like this. It was question number 12. And we have already done the first part. Still, we need to do the second, third, fourth part. In the question, it was given that A, B, C, D. Yeah, here we have done one construction by ourselves. That is this C is parallel to AD. That is what we have done the construction. It was given in the question that AB is parallel to CD, and it was also given that AD is equals to BC. Okay, we have proved the first part. Angle A is equals to angle B. We have already done the proof of that this angle and this angle is same. Before that, we have also proved that this A B A E C D is a parallelogram. We have proved that AECD is a parallelogram. Okay, where the opposite sides are parallel and obviously are equals to each other. Now, since it's a parallelogram, can we say angle A plus angle D is equals to 180 degree? The sum of adjacent angle of a parallelogram are supplementary with each other. You can say adjacent angle of a parallelogram are supplementary with each other, or sum of adjacent angle are 180 degree. Okay. Similarly, we can also take angle B plus. Okay. Instead of B, we will be taking over here angle E plus angle C is equals to 180 degree. Now, previous day we have taken this this side and this side was of same length. It's an isosceles triangle. From the given condition, if you have noted down, if you have taken the note of the previous day class, we have already figured it out that BC and CE are of same length. So, and also we were saying that this angle and this angle are same. This angle, if this is X, that is X. Okay. So we are saying the two oranges are same, the two blues angles are same. We have to prove here as a second part that angle C is equals to angle D. All right. Let's see how can we do so. Angle C means this angle C, and angle D means this angle D. That's what we have to prove. So let's see what we can do. Okay, rather than taking the isosceles triangle, we can also take one thing over here, that since AB is parallel to CD, which is given in the question itself, can we say BC is a transversal? And two parallel line cutted by a transversal like this, then sum of interior angle on the same side, sum will be 180 degree, or if you call it co-interior angle, the sum of this angle B and angle C will be 180 degree, right? So let's write it. Angle B plus angle C will be 180 degree. Why? These two are interior angle on the same side or co-interior angle. So let's write it. These two are co-interior angle. Now equation 1 and equation 2, if we will compare, that is also 180, this is also 180. So let's compare it from 1 and 2, or equating 1 and 2. We will be saying A plus D is equals to B plus C. Already we have proved in the first part that A and B are same. Okay, so instead of A, we can write A as a B, or we can also write B as a, right? Let's write it. This is B, this is D, this is also B, is equals to B plus C. We can cancel them out, and hence we got angle D is equals to angle C. Let me summarize what we did over here. So we are saying that since A, E, C, D, it's a parallelogram, or forget about parallelogram. We are saying that since AB is parallel to CD, then sum of this angle and this angle will be 180 degree. Co-interior angle or interior angle on the same side. Similarly, sum of those two angles, sum of this angle and this angle will also be 180 degree. Co-interior angle or interior angle on the same side. Now we are just comparing both the equation. Already we have proved that angle A, angle B are same. So that we are using the condition which we have proved in part A. And then we ended up getting angle C is equals to angle D. Is it clear? Now the next part is asking that prove that, we have to prove that, the third part says that prove that triangle ABC is congruent with triangle BAD. Let's see which one is triangle ABC and which one is triangle BAD. For that we need to draw the diagonal in this trapezium. So let's draw the diagonal. Okay, ABC and BAD. BAD. Let me mark the triangle properly so that you can see the figure. ABC, this one, and BAD. This one, the sky triangle and the pink triangle, both the triangle we have to show it's a congruent triangle. AB, you can see that is a common side over there. So we can write AB and AB are common side. Next, what is same? So we know that AD and BC are same. That is already given in the question itself, that pink triangle, one of the side AD, and sky triangle, another side BC, both are equal with each other. Let's write it. AD is equals to BC. Pink triangle is having angle A, the total angle A, and sky triangle is having total angle B, which we have already proved as a same in the first part. Let's use that. Angle A over here, that is, okay, angle B over here, ABC, sky triangles angle B is equals to pink triangles angle A, BAD. Okay, already proved in the first part. Now, which congruency criteria is getting fulfilled? I have already said to you to check which congruency criteria is getting fulfilled. We will be focusing on any one of the triangle, either the sky one or the pink one. So if we are going to focus on the pink one, this side we have used. If we are going to focus on pink one, this angle we have used. And if we are going to focus on pink one, this side also we have used. So what exactly we have used? Side angle, side congruency criteria is getting fulfilled, and hence these two triangles are congruent with each other. Is it okay? Now there is one
Yes,
more
ma'am.
part which says that show that diagonal AC is same as diagonal BD. So from here only, from our triangle only, we can say that since this two triangle congruency we have proved, so AC and BD will be same by CPCT. Alright. Hence we are done with the first exercise, which was totally based on parallelogram, rhombus. Like these properties of parallelogram was there, quadrilateral family was there, and everything. Now let's move to the next part, that is midpoint theorem. What the theorem says, let's try to understand at first. Let me write the theorem so that you will be able to connect what the statement says and what I am explaining over here. So the theorem says the line segment joining the midpoint of two sides of a triangle is parallel to the third side. Let's try to understand this theorem, then we will be also discussing here the converse of this theorem. So what the theorem says the line segment joining the midpoint of two sides of a triangle. We are having a triangle. Okay. Now the line segment joining the midpoint of two sides. Any two side you take it from this triangle. This is triangle ABC. Now if you want to take any two side, just take it. So I am taking side AB and side AC. Okay. And I am taking the midpoint of the two sides. So midpoint of this one is M, let's say, and midpoint of that side is N, let's say. If we will join this two midpoint, this line MN will be parallel to BC. This line MN will be parallel to BC, and there is one more condition, and will be equal to half of the length of third side. So this MN, when we are joining two midpoints, then the line segment, whatever we will be getting, that will be parallel to the third side, and it will be equal to the MN will be equal to half of the length of the third side. Okay. Now the same, if you want to take another triangle, let's take it. If we are having triangle PQR, what the theorem says, try to understand, then only you will be able to apply this theorem. Two sides midpoint you have to take. So if I am taking midpoint of this side, let's say S, and if I am taking midpoint of this side, let's say T. Both the midpoint I have taken, and if we will join the midpoint, it will be parallel to the third side. Third side means the side which we have not touched till yet. Okay, so this ST will be parallel to the third side, and ST will be half of the length of third side. This is what the theorem says. Any any two side of a triangle you take, and if both the sides midpoint you will join, you will be getting a line segment which will be parallel to the third side, and its length will be half of the length of the third side. That's what the theorem says. Okay, now converse of the theorem. Just a second. Okay, so rather than seeing the converse statement, let me explain the converse of the theorem, what exactly the converse of the midpoint theorem says. If we are having a triangle, and if you are taking one of the sides midpoint, any one side's midpoint. If this is a triangle ABC, so any one of the sides midpoint you are taking. So let's say you are taking the midpoint of this one, M. Now if you are through the midpoint, if you are drawing a line you are going to draw which is parallel to the other side. Through the midpoint you are drawing a line which is parallel to the other side. So you know here M is the midpoint of AB, and through M you are going to draw a line. Let's say a line MN. MN is parallel to BC, that much you know. Then this N will be midpoint of the other side. That's what the converse of the theorem says. That if you are taking one of the sides midpoint and drawing a parallel line, a line which is parallel to the other side of the triangle, then you then the other end point, or the line segment, the end point of the other, what we can say, this line segment we are having MN, okay, it will be the n will be the midpoint of the other side. That's what it says. Okay, let me explain it a different way also. If you are having a triangle, let's say PQR, you are taking midpoint of one of the side. Here let's say you are taking midpoint of this side. Through this midpoint if you are drawing a line, okay, and that line if it is parallel to one of the side, so if you are drawing a line parallel to one of the side like this, okay, let's say ST, you have drawn parallel to PQ, then T must be the midpoint of PR. This is what the theorem says. The first theorem says that when you will be joining two midpoint, you will be getting a line parallel to third side. Here the converse of the same theorem, the reverse part of the same theorem says that if you are taking one midpoint, drawing a parallel line, it must be the midpoint for the other side also. That's it. Now let's solve few questions to understand this theorem clearly. So here we are having a quadrilateral ABCD. P, Q, R, S. ABCD is a quadrilateral in which PQRS are the midpoint of the side AB. Okay, A, B, CD is a quadrilateral in which PQRS are the midpoint of the side AB, side BC, side CA, like side CD and side DA. Okay, these all are the midpoints. It is clearly written in the question that P, Q, R, S are the midpoint of side AB, BC, CD and DA. Show that SR is parallel to AC and SR is half of AC. We also have to show that PQ is equals to SR. We also have to show this, and the third part, that is PQRS is a parallelogram. Let's do one by one. So the first part says we have to show that SR is parallel to AC. Where is AC? AC is nothing but just the diagonal AC. This is AC. We have to show that SR is parallel to AC and SR is half of AC. So we can say that in triangle ACD, in triangle ACD, here we can say that R and S are midpoint. So we are having D over here, A over here, and C over here. Okay. We have taken midpoint of, in this triangle, we have taken midpoint of this side and midpoint of this side. What we are doing, we are joining the midpoints. Okay. Like this. So obviously now only the midpoint theorem says that when you will be joining the midpoint of two sides, it will be parallel to the third side. So obviously this RS will be parallel to AC, or SR will be parallel to AC. SR, RS is the same thing. That's what we have to prove here. We can write that by midpoint theorem. SR will be parallel to AC. First thing first, you need to write that in triangle ADC, okay, R and S are the midpoint. Therefore, RS will be parallel to AC by midpoint theorem. Nothing else. And also, SR will be equals to half of the length of AC. We are done with the first part. We don't have to do anything else. We just needed to write that we identified the triangle. We can see midpoint is given. Hence, by midpoint theorem, first part done. What about the next part? The next part says PQ and SR are same. For to prove that PQ and SR are same, we will be focusing on this triangle, the yellow triangle now. And in the yellow triangle also, we are going to say the same thing. What we are going to say in yellow triangle also, we will be saying that in yellow triangle, side BC. Now once we will join, it will be parallel to is AC, and PQ will be equals to half of the length of the AC. This is equation number 2. This was equation number 1. Now if you will compare 1 and 2, can you see SR is half of AC, PQ is half of AC. So obviously from 1 and 2, SR and PQ are same. That's it. That's what we needed to prove over here, that PQ and SR are same. One more thing we will be getting from 1 and 2, SR is parallel to AC, PQ is parallel to AC. So SR, PQ, AC, all are parallel with each other. From 1 and 2 only we have got. So SR is equals to PQ, and here SR is parallel to PQ also. So it's a parallelogram. SR, which one is a parallelogram? This one. This SR is parallel to PQ and SR is equals to PQ. We have proved already. So we can say this total is, since opposite sides are parallel and equal with each other, it's a parallelogram, and hence we are done with this part. Is it clear? Do let me know. Do let me know whether it is clear or not. We will be moving to the next part. Okay, let's move ahead. ABCD is a rhombus, and PQRS are midpoint of side AB, BC, CD, and DA respectively. Show that quadrilateral PQRS is a rectangle. We have to show that the quadrilateral PQRS, once we'll be joining them, it's a rectangle. Let's draw the figure first. ABCD is a rhombus. Let's draw a rhombus. A, B, C, D. What is the property of rhombus? AB, BC, CD, DA, all will be of same length. What else is the property of rhombus? We know diagonal of a rhombus bisect each other at right angle. These are like few properties which we know already about the rhombus. Okay, let's see whether we can use this in this question or not. So ABCD is a rhombus and PQRS are the midpoint of side AB, BC, CD, DA. So PQRS are the midpoint of side AB, BC, CD and DA. Let's join. It says that prove that show that quadrilateral PQRS. Can you see it's a quadrilateral four-sided polygon? It's a rectangle we have to prove. We have to show that it's a rectangle. First thing first, if we will be able to prove that PQRS is a parallelogram, and then if we will be able to prove that one of the interior angle is 90 degree, then we can say that surely it's a rectangle. First thing first, we will be able to show that it's a parallelogram. Opposite sides are parallel and equal, just like the previous question by taking the help of the diagonal. After that, we just have to prove that one of the interior angle, one of the interior angle of this parallelogram is 90 degree, and then surely we will be able to declare that it's a rectangle. Okay, let's do that. So let's take the help of diagonal. Just like the previous question, we will be drawing a diagonal. Let's say diagonal AC. Now in triangle ABC, midpoint theorem we can apply and we can say PQ will be parallel to AC and PQ will be equals to half of the length of AC. In the other triangle ADC, what we can say? SR will be parallel to AC and SR will be equals to half of the length of AC. If you are not understanding it, we are just applying the midpoint theorem. Okay, we are just joining the midpoint of two side. It will be parallel to the third side of the triangle. That's what we are saying. Which statement we need to write over here? No other statement we need to write over here. In bracket we will be writing by midpoint theorem. That's it. So from equation 1 and 2 we can say PQAC are parallel, SRAC are parallel. So PQSR will be parallel. Similarly, PQSR will be equal from 1 and 2. Then therefore, PQRS is a parallelogram. Easily we have proved that PQRS is a parallelogram where opposite sides are parallel and equal with each other. What is the other property of parallelogram? Opposite angles are also same. In a parallelogram, opposite angles are also same. That we already know. So PQRS is a parallelogram. We have proved that. Let's keep it aside. Now let's say we are drawing both the diagonal of Am I audible?
Yes, ma'am.
Riyaz, am I audible? Okay. Okay, I am audible. So here we know that in a rhombus, diagonal bisect each other at right angle. So this is 90 degree. We already know. Not only this, all the like all the angle, this one, this one, this one, all are 90 degree. We already know. We just have to take any one of the quadrilateral from here. Okay, why we are taking one of the quadrilaterals? So that we can go ahead and we can prove that the one of the interior angle of this parallelogram PQRS is of 90 degree, hence it's a rectangle. Okay, so now we are going to focus on, now we are saying that in quadrilateral OMSN, we know that one of the angle is 90 degree. How we know that? Because it's a rhombus and diagonal bisect at right angle, that we already know about rhombus. That's why I have marked 90 degree over here. What we want to prove over here? We want to prove that one of the interior angle of this one is this one is 90, or maybe this one is 90, or maybe this one is 90, or maybe this one is 90. If any one of the green one, we will be able to prove that it's a 90 degree, we can say it's a rectangle. And that's why we are taking the smaller teeny tiny quadrilateral, or you can say that one. Yeah, that quadrilateral we are taking. Now we will be going ahead to prove that the opposite angle is also 90. How we will be doing so? Please see carefully. So in quadrilateral OMSN, just keep your eyes on OMSN. Okay. We are talking about this one. This quadrilateral OMSN. Now what we know? We know that NS is parallel to, like, the total, first thing first, we know that this PS and BD are parallel. How? By midpoint theorem. We know that it is making a triangle, and midpoint joining two midpoint will be parallel to the third side. So PS and BD are parallel, that we already know. So can we say, since PS and BD are parallel, so obviously a part of PS will be parallel to a part of BD. Previous day I was showing you, when we will be extending the parallel line, still it will be parallel to the other line. When we will be cutting out a parallel line, still it will be parallel to the other line. Okay, so since PS and BD are parallel, how? By midpoint theorem, therefore NS and OM will be parallel. Let me write it. NS is parallel to OM. How do we know that? Since PS was parallel to BD by midpoint theorem. Similarly, the other two side also, I am going to say that it's parallel. How? I am going to say that this side and this side are also parallel. Why? Why? Because we know that SR is parallel to AC. So obviously a part of AC will be parallel to a part of SR. Okay. So SR, here you can see SR parallel to AC. Already we have written by midpoint theorem. So that only we are going to use. And on the basis of that only I am going to say that ON and MS are parallel. Okay. Let's take that. ON is parallel to SM. Why? Why? Because SR was parallel to AC. Now in this smaller quadrilateral OMSN, opposite sides are parallel with each other. Hence it's a parallelogram, right? Previously we said that it's a quadrilateral. Now we can declare that it's a parallelogram. OMSN. OMSN is a parallelogram. N is a parallelogram. And in a parallelogram, there is a property that opposite angle of a parallelogram are equal with each other. So if angle O is 90 degree, then we can say angle S will also be 90 degree over here. Okay. So angle O is equals to 90 degree, or you can just name it properly. That is angle NOM or MON is 90 degree. Let's write it. Angle MON is 90 degree, which we have got from the rhombus property, that diagonal bisect each other at right angle. This was already written in the question that it's a rhombus, and hence we are saying MON is 90 degree. Therefore, opposite to MON, this angle S will also be 90 degree. Okay. So angle NSM or MSN, this will also be 90 degree. Angle MSN will also be 90 degree. Therefore PQRS, which we have proved as a parallelogram initially, now we can say it's a rectangle. Therefore PQRS is a rectangle. Now let me summarize what we did over here. Okay. So we are having a quadrilateral ABCD over here. Let me start from the very beginning. We are having a quadrilateral. Okay, it's not a quadrilateral, it's a rhombus over here. ABCD is a rhombus over here. A, B, C, D. It's a rhombus over here. What we are doing? We are just in this rhombus, midpoint of each and every sides are given. That is P, Q, R, S. Now, once we are joining the midpoint, then we are getting a rectangle. That's what we have to prove here. Okay, that means if we will be proving this as a 90 degree, any one of the angle, then we can say it's a rectangle. But only 90 degree will not work. First thing first, we have to prove that it's a parallelogram, and then if we will be proving that one of the angle is 90, then only we can say it's a rectangle. Why only 90 degree will not work? Because 90 degree means one of the angle is 90 degree, and if you are making a figure like this, obviously it's not a rectangle. So if you will, from the very beginning, if you will be having in your mind that let's go ahead and prove one of the interior angle as a 90 degree, that will not justify that it's a rectangle, because you can see it's not a rectangle. Only 190 degree will not declare that it's a rectangle. So that's why first thing first, we are going to prove that it's a parallelogram. And then if we will be proving that one of the interior angle of this parallelogram is 90 degree, hence it's a rectangle. Okay. Now since ABCD was already given as a rhombus, we already having one information in hand, that is four side of this rhombus will be same, and the diagonal of this rhombus will bisect each other at right angle. Each and every angle will be right angle. Okay. So first thing first, we are going to prove PQRS is a parallelogram. Easily we will be able to prove that by using the property of midpoint theorem. That triangle, this triangle, both are parallel, both are equals to half of AC. And then we can compare, like this PQ is parallel to RS, PQ is equals to RS, hence it's a parallelogram. So midpoint theorem, easily we will be able to prove that it's a parallelogram. After that, we need to take any one of the quadrilateral from here. Any one. Either this one or this one or this one or this one. Any one of the quadrilateral we can take from here. Why? Because we want to prove that interior angle of this parallelogram is of 90 degree. So we are taking this one, and we are able to say that this is also a parallelogram. For that, we don't have to uh, we don't have to apply any extra effort. Already PQ and BD was parallel, so a part of PQ and a part of BD must be parallel. Already QR and AC was parallel, so a part of QR and a part of AC must be parallel. If you know about parallel line, two lines are parallel, then if you will rub some part of this line, then still it will be parallel to the other line. Okay, so I am saying if these two lines are parallel, then if you will erase it, still both are parallel. If you will erase it, still both are parallel. If you will erase it more, still both are parallel. That condition only we are applying over here. Okay, that earlier it was parallel, so hence this teeny tiny quadrilateral, it's a both the opposite sides are parallel with each other, and hence we already know that this is 90 degree. Then we can say this will also be 90 degree, because opposite angle of a parallelogram are equal with each other. And hence if angle Q is 90 degree, then we can, because PQRS was a parallelogram, and then this parallelogram angle Q we have shown as a 90 degree, then it's a rectangle. Is it clear?
Yes, ma'am.
Is it clear to everyone?
Yes,
The next theorem says that ABCD is a rectangle. Again, PQRS are midpoint of side AB, BC, CD, and TA, respectively. Show that the quadrilateral PQRS is rhombus. Just the reverse of the previous theorem is given over here. It's a rectangle, show that it's a rhombus. Again, we need to prove that first thing first, it's a parallelogram, and then we will be thinking about rhombus. So if ABCD is a rectangle, I'm going to leave this theorem for you. You try it and do let me know whether you are able to do it or not. Okay, I'm just going to give a hint over here. This is P, this is Q, this is R, this is S. If we will be joining them, we will be getting a rhombus. That's what we have to prove. ABCD is a rectangle already given. ABCD is a rectangle and PQRS are the midpoints. That much is already given. So hint, note it down. Prove that PQRS is a parallelogram by using midpoint theorem. With the help of diagonals. Note it down. First thing first, you are going to prove that it's a parallelogram, which is very simple to prove. You just need to draw the diagonal, and then you will be able to prove that PQRS, any one of the diagonal will help you. It's a parallelogram. One, now our next thing is so either this triangle with the parallelogram, that means you have already proved that PQRS is a parallelogram where opposite sides are parallel and are equal with each other. Now, by taking this two triangle as a congruent, so opposite sides, okay, where I same group sides are same with each other. That's what you are saying, and hence you can say it's a rhombus. So the next part hint, you just note it down. The next part for the hint is to prove SRD, triangle SRD is congruent with triangle QCR. While proving the congruency of this two triangle, you will you need to use the midpoint. Like since AD and BC both are equal with each other in a rectangle, opposite sides are equal, so AD and BC are equal, so half of AD, that is SD, and QC will also be equal. This and this will also be equal. That information directly you can use over here. Okay, since it's a rectangle, opposite sides are same, then half of opposite side will also be same. This way you can use the information to prove that it's both the triangle are congruent triangle. Here 90 degree, there also 90 degrees, since it was a rectangle. That too you can use for proving the congruency. Okay, so prove the congruency, and therefore we will be getting SR is equals to QR by CPCT. Let me write the name of the triangle properly, because here I can see the name is not proper. It will be QRC. SRQR are same by CPCT, and then we can say that it's a rhombus. You just do this much. We will be discussing about it in detail. If you can do, well and good. If you can't do, I'll be taking it from the very beginning and will be explaining the whole thing. Okay, so do try it and do let me know in the next class whether it was possible for you to continue and to prove that till here at least SR and QR are same or not. Okay. Now, if you are having any doubt over here or in any of the theorem which we have discussed till now, please do ask. Any doubt?